Okay, this one will be quick. If you wanted to do this, again, I would do the area of all the sides you can see. Leave that last one as your last step because it's a little trickier. So I'm going to do the prism first. So if I look at that front face, that's 3 times 6. I'm going to times it by 2 because there's 2 sides that are the exact same. That gives me 36. That's the front and the back. Then I'm going to do the top. The top is 4 times 6. Again, I'm going to times it by 2 because I can see the bottom on this guy. So it's going to be 48. Then I'm going to look at the left side. This side over here. The area of that side would be 4 times 3, which is 12. And then I've got this side over here. Okay. I would find that, calculate that area, subtract the circle where it's overlapping. That's what I would do.
So take away one.
You need to take away the area of that circle. So the way you find that area of that circle will be using this formula. And that would legitimately work. Like that strategy would work. However, there is a quicker way to get through these problems if you're able to vision it in a different way. So I know when I'm calculating the area, I'm going to have to subtract away that circle, but later on, I'm going to be adding the area of the circle again anyway. So what you could do is you could do the area of this rectangle, not subtract away the area of the circle, and then just not add the area of the circle on the top. Because essentially what you're doing is you're subtracting away what you're adding later. Right? So this circle right here, we could just pretend is against the rectangle to fill that whole rectangle in. So it is kind of a quicker way to get through things if you wanted to do it that way. But it's just up to how you see things. Right? So for me, I would then just go 3 times 4 to be 12. And I'm not going to include the area of the circle because I know the area of the circle is in there. It's in that calculation I just made. My final calculation will be the cylinder part of that. A reminder of how to calculate like that round part of a cylinder is that you do the diameter. You do the circumference that's around the circle times the height of that thing. How do you calculate circumference of a circle?
Do the diameter. That's what circle is.
Nick, what's the area for circumference of a circle?
Let's see.
Do you remember? Oh, I thought you had your hand up to answer it. Circumference of a circle. Anybody remember the calculation for it?
2r pi.
Yeah, close. Just for circumference, you wouldn't have to do the height, but that would be the whole area. 2 pi r. That would give you the circumference of a circle. You could also do pi times diameter. Right? Because 2r would give you the diameter. It's doubling it for you. So for us, the circumference of this circle would be pi times 1, which is just pi. Yeah. You have to get the circumference because the area of this part right here, I'll point with my finger. is the height of the cylinder times the circumference of the cylinder.
Oh, okay. I just made that as one equation.
Yeah, so you did the 2 pi r height.
Yeah.
Yeah. And that's the same thing.
So it's like 2 pi r equals pi times diameter.
I like to do the area of that outside of the cylinder as circumference times height. If you use the formula 2 pi r h, it's the same thing. Right? Those literally are the same thing. It's just I'm breaking it down into two chunks. So for us, our height was 3 times our circumference, which was pi. And that gives you 9 point, I don't know, something bad. 4.2? We'll just do 4.2 for now. Again, if you want to calculate the total surface area, you are going to add all those numbers up. When you add them all up, 117.42, maybe? I don't trust myself. My brother's like a human calculator, but I'm not. Is that what you got?
Yeah.
117.42?
I don't know if that's right though.
There's no way we both got it wrong, right? If you add them all up, it's 117.42.